Here's another example of calculating with the multinomial theorem. It looks at first like a multinomial theorem, but I want to point out on this problem how there are several ways that you could rewrite it if you wished. It's got I equals 0 to 5 factorial over I factorial 5 minus I factorial. And then negative 3 to the I, 4 to the 5 minus I. So actually it's closest at first to being to looking like a binomial theorem. But a binomial theorem is just a special case of the multinomial theorem. So let me first point out that you could rewrite this as I equals 0 to 5. 5 choose I. What's right above there is exactly the formula for 5 choose I. Just has a variable there. 5 factorial goes on top. I factorial times 5 minus I factorial. And then the rest of this would be negative 3 to the I, 4 to the 5 minus I. Now, we could finish solving it at this point. Or, if we wanted to see one more way that you can write it, one more way that you could write it is like this. So, I did the first two. I had I equals 0 to 5, kind of the old-fashioned way of writing a sum. But this way says I plus j equals 5 underneath, nothing on top. And so it is supposed to indicate that, and you really should say this as well here, I and j are both larger than 0 or equal to 0. But you're supposed to sum over all the possible ways of two numbers adding up to 5. Well, that is exactly like these two numbers, I factorial and 5 minus I factorial. Those are the two numbers that add up to 5. So I'm just replacing 5 minus I with a j. So in other words, this inside would just be 5 factorial, I factorial, j factorial. And then the rest of it being the same. Negative 3 to the I, 4 to the 5 minus. So, this time I would write 4 to the j. So there's more ways to write it, of course. I mean, here's one more just to be extra. You don't need to use those same letters, I and j. You can call them anything you want. So, that has j1 plus j2 equals 5. I'm just calling it j1 and j2 instead of I and j, just to make sure that's clear. Then it's got 5 factorial over j1 factorial, j2 factorial, and negative 3 to the j1, 4 to the j2. So you get to pick your favorite. Any of those are exactly the equivalent to the first one. And as you do enough of them, you don't need to rewrite it any of the three ways. You could see it from the first one. It's just recognizing that it has the right coefficient out front, which is either a combination or a multi-combination. Oh yeah, we could also write that multi-combination different ways too. You can write it with the, multi-permutation. You could write the multi-permutation with the just like with the parentheses, but with I comma j, or just ij in the string underneath. Okay, so Now that we've rewritten it several ways, we might as well answer it. So all of them come out to the same thing. You pick whichever one you think is easiest to look at. And you see that the important thing is that it has two terms. Or, if you're looking at binomial, that it's a binomial theorem. So it's either a multinomial with two items or a binomial. Means the same thing. And that it goes to 5. 5 is definitely there every single time. So now that I know there's only two items being added together, or a binomial, that means when I look at the end of the problem, there's no need for an extra multiplied on by 1 or something like that. Instead, I just have -3 and 4. So -3 plus 4. And the big number 5 is the power. So we're using the binomial theorem or the multinomial theorem. You get the same exact answer there, and that simplifies really fast, right? 1 to the 5 equals 1. So all that work to get the answer of 1, but I just wanted to go over some of the multiple different ways that you can write the same thing with this kind of math.